From the instant recommendations popping up on your screen
Hmm.
to the unseen intelligence that might be helping with medical diagnoses, AI isn't really futuristic anymore.
No, not at all.
It's woven into, like, the very fabric of our daily lives,
Yeah.
and it's constantly evolving. But the question is, how much do you truly know about the intelligence that's shaping your world? So today, we're doing a deep dive into artificial intelligence.
Mm-hmm.
Our mission, well, it's to journey from its basic concepts, its sometimes surprising history,
Mm-hmm.
through its cutting-edge uses, and really get into the crucial ethical questions it raises. And also touch on the exciting potential of humans and AI working together.
Yeah.
We want to give you that shortcut to being genuinely well-informed, packed with insights, maybe just enough humor to keep you hooked.
And to do that, we've gathered, well, quite a stack of sources, everything from, foundational academic texts and encyclopedic knowledge to really specialized technical articles, the latest industry reports, and some pretty thought-provoking analyses from the leading experts. The goal is really to distill the most important nuggets of knowledge, the key insights, helping you grasp not just what AI is, but, why it matters so much now and where it might be heading.
Exactly. Think of this as your essential guide. Understanding AI's inner workings, its profound impact, and the critical questions we all need to be asking.
Mm.
Okay, let's unpack this.
Yeah.
So, when we talk about machines showing intelligence,
Yeah.
where do we even begin? I mean, Alan Turing, way back in 1950,
Yeah, the pioneer.
he suggested a fundamental shift, right? Instead of asking if a machine can think, he said, look, let's ask whether or not it is possible for machinery to show intelligent behavior.
Mm-hmm.
He kind of steered us towards observing what machines do rather than getting bogged down defining if they have a mind like ours.
Right. And that distinction was crucial. It set the stage. The pioneers who came after, like John McCarthy, one of the actual founders of the term AI,
Okay.
he defined intelligence as the computational part of the ability to achieve goals in the world.
Computational part.
Yeah. And Marvin Minsky, another giant in the field, he boiled it down to the ability to solve hard problems.
Simple but powerful.
Essentially, yeah. Most leading AI definitions focus on agents, systems that perceive their environment
Okay.
and then act in ways that maximize their chances of achieving specific, defined objectives. It's all about purposeful, effective action, computationally speaking.
And when you look at AI textbooks, how they outline the field's goals, these ideas become pretty concrete capabilities,
Mm-hmm.
like reasoning and problem solving, that's the classic one. But also knowledge representation, how machines store and understand information, planning, decision-making, learning itself is a key goal.
Learning is huge.
Then there's natural language processing, NLP, understanding and generating human language, perception like computer vision. They're even tackling social intelligence, trying to recognize and simulate emotions.
Which is incredibly complex.
And the ultimate goal, the big one, is artificial general intelligence, AGI. A machine that could solve a wide variety of problems with, like, human-level breadth and versatility. It's actually easy to see how these sort of academic goals translate into the smart tech you interact with every day, often without realizing it. Now, to really get where we are today, we kind of need to understand the journey. Let's rewind a bit. See how AI evolved through these pretty dramatic ups and downs.
It's quite a story.
The philosophical ideas, they go way back, right? Antiquity, studying formal reasoning. But fast forward to the 1940s, you get Alan Turing's theory of computation.
Mm-hmm. The Turing machine concept.
Yeah, that a machine shuffling zeros and ones could basically simulate any mathematical reasoning.
Mm-hmm.
And his 1950 paper really argued that machine intelligence was plausible.
And that plausibility got, well, very real at the official birth date of AI research,
Yeah.
the Dartmouth College Workshop in 1956.
Like that's the famous one.
Yeah, it was a watershed moment. The term artificial intelligence was actually coined there. The researchers involved went on to lead the field for decades, and their early programs were honestly astonishing for the time.
Like what?
Imagine a computer in the 50s learning checkers strategy, solving algebra problems, proving logical theorems, even processing basic English.
Wow. In the 50s, that
Yeah.
must have felt like the future had arrived.
Totally. And that led to this huge wave of maybe over-optimism.
Oh, okay.
Herbert Simon, 1965, famously predicted machines doing any work a man can do within 20 years.
20 years.
Yeah. And just 2 years later, Marvin Minsky thought the whole problem of AI would be substantially solved within a generation.
They really underestimated how hard the real world is.
Massively.
Yeah.
And that underestimation led directly to what we now call the AI winters.
Right. The funding cuts and the skepticism.
Exactly. These weren't just small setbacks. They were serious periods of disillusionment, one in the 70s, another in the late 80s, driven by those overly ambitious promises, critical reports like the Lighthill report in the UK.
Which questioned the progress.
Yeah, questioned if it was delivering. And of course, government funding cuts followed.
Right.
But, these winters also forced the field to get real, to confront its limitations, pivot its methods, and actually build stronger, more realistic foundations for the future. It taught resilience.
It's true. AI seems incredibly resilient, and it did revive in the early 80s, partly thanks to expert systems.
Yeah, those had some commercial success.
Programs mimicking human experts in specific areas. But this era also saw a really crucial shift, didn't it? Away from just pure logic rules towards subsymbolic methods.
That's key, the revival of connectionism.
Connectionism.
Neural networks. Exactly. The idea of interconnected networks, including neural networks, which folks like Geoffrey Hinton had been working on.
Okay, so the C's were there.
They were. And that leads us right into the deep learning revolution, which just exploded between, say, 2012 and 2015.
And the fascinating thing is, it wasn't some brand new theory, right?
Not really. Deep neural networks, the core algorithm called backpropagation, which is how networks learn from mistakes by adjusting connections that stuff had been described decades earlier.
So what changed?
It was this powerful convergence. First, an incredible increase in computer power. Specifically GPUs.
Graphics cards.
Graphics processing units, yeah. They offered like 100-fold speed increase for the kind of parallel math needed to train these deep networks, sometimes called Huang's Law after NVIDIA's CEO. Combine that massive compute power with vast amounts of training data, huge data sets like ImageNet.
Right, millions of labeled images.
And boom, the revolution ignited.
It's a fascinating ebb and flow, isn't it? That persistence through the lean years, the AI winters, and then the right combination of factors, compute, data leading directly to the breakthroughs we see now.
Okay,
so let's dig in. Here's where it gets really interesting. What are the actual fundamental techniques powering AI behind the scenes?
Right. Under the hood, AI systems rely on a few core families of techniques. First up, search and optimization.
Finding the best answer.
Basically, yeah. Finding the best path or solution among potentially countless options. This includes things like state space search, systematically exploring possibilities, or local search algorithms like gradient descent.
Which you mentioned for neural nets.
Exactly. That's how they tune themselves to get better. We also see cool nature-inspired stuff like evolutionary computation or swarm intelligence algorithms based on like how ant colonies or bird flocks optimize.
Okay, search and optimization, what else?
Then there's logic. Formal methods for reasoning and representing knowledge.
Like Sherlock Holmes-style deduction.
Kind of. It involves things like propositional logic, dealing with simple true-false statements, and predicate logic, which handles more complex statements about objects and relationships like, all humans are mortal. It's the foundation for deductive reasoning.
Got it.
And third, critically important, probabilistic methods. These are essential because the real world is messy, uncertain, full of incomplete information.
Right, not always black and white.
Exactly. So tools like Bayesian networks or Markov decision processes let AI agents make educated guesses, weigh probabilities, and update their beliefs as new information comes in. Crucial for planning, perception, things where you rarely have perfect certainty.
Okay, so those are the core tools. But how do the machines actually learn from all the data they get? That's where the different learning types come in.
Precisely. The most common one people hear about is supervised learning.
Learning with labels.
Yeah. The key insight is how labels allow a machine to predict outcomes. So if you want to classify emails as spam or not spam, you feed it thousands of examples already labeled. The machine learns the patterns, words, sender, format that correlate with spam. Then it can predict the label for new unseen emails. It's learning a mapping from inputs to correct outputs.
And that can be for categories, like spam, not spam.
Right, that's classification. Or it can predict a continuous value, like a house price that's regression.
So it learns with an answer key. But what if there isn't one? What if you just have a pile of data?
Ah, that's unsupervised learning. Imagine you have a massive data set, just the input features, no labels, no right answers.
Okay.
The machine's job is to find hidden patterns or groupings in the data on its own.
Like finding clusters.
Exactly. Finding natural clusters in customer data or maybe underlying themes in a bunch of text documents without any predefined categories. It helps you discover structures you didn't even know were there.
Interesting.
And a third really powerful paradigm is reinforcement learning.
Learning by doing.
Pretty much. An agent learns through trial and error by interacting with an environment. It gets rewards for good responses and punishments for bad ones.
Like training a dog almost.
Sort of. It gradually figures out which actions lead to the best cumulative reward over time. This approach was absolutely critical for breakthroughs like AlphaGo.
Ah, the Go playing AI.
Yeah, it learned to master that incredibly complex game largely by playing against itself, refining its strategy based on winning or losing that feedback loop.
Understanding these different learning styles really helps make sense of the different AI capabilities you see. Face recognition, recommendations, game playing. They often use different learning approaches. Okay, let's zoom in now on some specific, really impactful AI tools, starting with a big one for seeing the world.
Right, let's talk convolutional neural networks, or CNNs.
CNNs. Okay.
These are a special type of neural network where information flows forward, input to output. What makes them so revolutionary, especially for computer vision, is how they deal with the sheer complexity of images. Older models struggled with the curse of dimensionality, needing astronomical data for high-dimensional input.
Images have tons of pixels, right?
Right. Exactly. CNNs overcome this by mimicking parts of the human visual cortex. They use these small filters, like tiny magnifying glasses,
Okay.
that scan the image, looking for specific low-level features, edges, corners, textures. Crucially, they reuse the same filters across the entire image.
So it learns edge detector once and applies it everywhere.
Precisely. That's called shared weights, and they use pooling to shrink the data down. This makes them incredibly efficient at learning visual hierarchies. Simple features combine to form more complex ones and robust, to where the feature appears in the image. This architecture, plus the GPU acceleration we talked about,
Made modern computer vision possible.
pretty much, yeah.
And their impact is massive. Image recognition, AlexNet winning ImageNet was a huge moment.
Absolutely seminal.
Video analysis, even some natural language processing tasks, surprisingly. And games.
Yeah.
Checkers. Go. AlphaGo used CNNs heavily, right?
Yeah, for both its policy network deciding the next move and its value network evaluating the board position. CNNs were core to its success.
Okay, switching gears to unsupervised learning. You mentioned clustering. What about k-means clustering?
K-means.
Yeah,
It's a really popular and honestly quite intuitive algorithm. The goal is simple. Partition a data set into a pre-specified number, k, of distinct clusters. Group similar things together.
How does it work?
Imagine you have a cloud of data points. You want to sort them into, say, K3 groups. K-means starts by randomly picking 3 points as initial centroids, the centers of your clusters.
Okay, random starting points.
Then, step 2, assign every single data point to whichever centroid it's closest to. Now you have 3 rough groups.
Makes sense.
Step 3, recalculate the position of each centroid. Where's the new center of all the points assigned to that cluster? You move the centroid there.
So the center shifts.
Exactly. And then you just repeat steps 2 and 3, reassign points to the new closest centroid, recalculate the centroid positions over and over until the centroids stop moving much or the points stop changing clusters. The groups stabilize. You end up with clusters where points inside are close to each other and hopefully well separated from points in other clusters.
And that's super useful in the real world.
Immensely. Think about a bank wanting to target credit card offers. They don't analyze every customer individually.
Right.
They use k-means, maybe grouping customers by income, spending habits, age, creating distinct segments. Then they can design specific offers for each segment.
Customer segmentation. Makes perfect sense.
Yeah, but it's also used for grouping similar documents, image segmentation, grouping pixels in an image, even in some recommendation engines.
How do you know if the clusters are any good?
Good question. There are metrics. You want low inertia, which means points within a cluster are tightly packed together. And you want high separation between clusters, which things like the done index measure. Basically, tight groups far apart.
Okay, got it. So CNNs for seeing, k-means for grouping. What about the AI generating all this incredible text and images we see now? The stuff that feels almost like magic.
Right. That brings us squarely into generative AI and GPTs.
The buzzwords of the moment.
Pretty much. Generative AI is a subfield using generative models like large language models, LLMs, to create new content. Text, images, code, video.
Based on what it learned.
Exactly. They learn patterns from massive amounts of training data and then generate novel outputs that mimic those patterns. Generative pre-trained transformers, or GPTs, are really at the forefront.
Pre-trained. How does that work?
The pre-training is usually unsupervised. The model learns by predicting the next word or token in billions of sentences from the internet, books, etc. This builds an incredibly rich internal representation of language, facts, reasoning patterns. Basically how the world is described in text.
And then you fine-tune it.
Yes, often with techniques like reinforcement learning from human feedback, RLHF. That's where humans rate the AI's responses, guiding it towards being more helpful, truthful, and harmless.
And the results are, well, staggering. Generating human-like text, acing standardized tests.
Yeah, human-level scores on the bar exam, SAT, GRE. It powers services you know. ChatGPT, Claude, Gemini, Copilot.
And they're not just text anymore, right?
Yeah.
Multimodal.
Right. Models that handle images, video, audio too, and they're being integrated directly into web search, like Bing's Copilot using GPT-4 or Google's AI overviews using Gemini.
But there's a catch, isn't there? The hallucination problem.
Yes, the Achilles heel. Hallucinations are when these models generate plausible-sounding but factually incorrect or nonsensical information. They essentially make stuff up, but confidently.
Why do they do that?
It's inherent in how they work. They're predicting likely sequences of words based on patterns, not accessing a knowledge base of verified facts in the way a database does. RLHF and other techniques can reduce hallucinations, but they haven't eliminated them, especially for complex reasoning. The model doesn't inherently know when it's right or wrong.
So these incredibly powerful LLMs can sometimes just confidently lie. How do we make them more reliable for real-world use, especially when we need accurate current information?
That is precisely the problem that retrieval augmented generation, or ARA, is designed to solve. It's become a key strategic technique for actually deploying LLMs effectively.
ARA. Okay, what does that do?
So ARA optimizes the LLM's output by having it first consult an authoritative knowledge base, something outside its original training data, before it generates an answer.
Ah, so it looks things up first.
Essentially, yes. It's a brilliant workaround because fully retraining these massive LLMs every time information changes or you need specialized knowledge is incredibly expensive and slow. ARA avoids that.
Okay, so it's like giving the LLM access to a constantly updated library or database for specific queries rather than trying to cram everything into its initial training.
Exactly. Think of the LLM as maybe an incredibly fluent, creative, but sometimes forgetful or misinformed expert. ARA gives it specific up-to-date briefing notes before it speaks.
Got it. So it makes it more factual and current.
Right. The benefits are huge.
Mhm.
It's cost-effective. It ensures information is current if the external source is kept current. It builds user trust because you can often cite the sources it used.
Oh, that's important.
And it gives developers more control over the AI's responses by controlling that external knowledge base.
How does the process actually work?
Well, first you need that external data. You convert documents, databases, whatever, into numerical representations called embeddings using special AI models and store them in a vector database.
Okay, data prep.
Then, when a user asks a question, the system retrieves the most relevant chunks of information from that vector database based on the query's meaning.
Finding the right briefing notes.
Exactly. Those retrieved chunks are then used to augment the prompt that gets sent to the LLM, so the LLM gets the user's question plus the relevant factual context.
Okay.
Finally, the LLM generates its response, but now it's grounded in those provided sources. And crucially, that external data source can be updated independently, keeping the information fresh.
And how does semantic search fit into this?
Semantic search really enhances the retrieval part of RAG. Instead of just matching keywords, semantic search understands the meaning and intent behind the user's query.
So it finds more relevant stuff.
Precisely. It can scan vast, diverse databases more accurately, pulling out information that's conceptually related, not just textually similar. This gives the LLM better, more relevant context, leading to even better RAG output.
Okay, so these tools, CNNs, K-means, GPTs, RAG, they allow AI to be both broadly creative and precisely informed, solving huge challenges, but also, as we're seeing, introducing new complexities. Which brings us to the unavoidable flip side. This immense power comes with profound responsibility. Let's shift focus now to the really critical conversations around AI. The risks, the ethical dilemmas, how we navigate its future. It really is a double-edged sword.
Absolutely. And the concerns are wide-ranging. One major area is privacy and copyright.
Because AI needs so much data.
Exactly. AI's hunger for large amounts of data inherently creates tension. Think about virtual assistants constantly listening. There have been cases of companies recording private conversations. That raises huge privacy and surveillance questions.
Mm-hmm.
And while there are technical fixes being explored, like data aggregation or differential privacy to obscure individual data, the fundamental issue of what they do with the data remains. And the training data itself fuels copyright battles. Was all that web text, all those images, used legitimately?
That's a huge ongoing debate.
Definitely. Then there's the issue of dominance by tech giants.
The big players.
Yeah. Companies like Alphabet, Amazon, Apple, Meta, Microsoft, they control most of the cloud infrastructure, the massive computing power needed for cutting-edge AI.
Right.
This concentration of power entrenches their market position, makes it really hard for smaller players or startups to compete, and could potentially stifle innovation and diversity in the AI ecosystem.
Some to watch. What about the environmental cost?
That's becoming a massive concern, too. Power needs and environmental impacts. Training and running large AI models consumes enormous amounts of electricity.
I've heard staggering numbers.
Yeah, the International Energy Agency forecasted AI's power demand could double by 2026, potentially reaching the total electricity use of Japan.
Oh.
This growth obviously raises concerns about energy sources, potentially increasing fossil fuel use. Now, the tech companies argue AI will also make grids more efficient and could even help manage things like nuclear power. We've seen Amazon buy a nuclear-powered data center, Microsoft agree to help reopen 3 Mile Island. So it's complex.
A definite tension there. And what about misinformation?
That's a huge one. Misinformation and deepfakes. We already saw how AI recommender systems on social media, aiming just for engagement,
Kept people clicking.
inadvertently created filter bubbles and amplified misinformation, conspiracy theories, and extreme partisan content.
Right.
Now, add generative AI. It can create images, audio, video that are virtually indistinguishable from reality. Exactly. This makes it incredibly easy for bad actors to create mass misinformation or propaganda. Geoffrey Hinton specifically worried about AI enabling authoritarian leaders to manipulate electorates. It's a serious threat to informed democracy.
And the bias issue. We hear a lot about biased algorithms.
Algorithmic bias in fairness is a critical and, frankly, quite disturbing problem. There's a famous example, the Compass software used in some U.S. courts to predict recidivism risk.
Okay.
Even though it didn't explicitly use race as an input, studies found it consistently showed racial bias. It overestimated the risk of reoffending for Black individuals and underestimated it for white individuals.
How does that happen if race wasn't an input?
Because the historical data it was trained on reflected existing societal biases and systemic inequities in arrest and sentencing. The AI learned those patterns. It proves that fairness through blindness, just ignoring sensitive attributes like race, often doesn't work. If the training data is biased, the AI prediction will likely perpetuate that bias.
That's deeply concerning. And it ties into the black box problem, right? Not knowing why the AI makes a decision.
Precisely. The lack of transparency. Often, especially with complex deep learning models, no one knows exactly how it works internally. This can lead to unintended learned behaviors.
Like what?
Well, there was an AI that got good at diagnosing skin cancer from images, but it turned out it had partly learned to associate the presence of a ruler in the photo, which doctors often included for scale in cancer images, with malignancy.
Whoa.
Another system classified asthma patients as low risk for pneumonia complications, not because asthma is protective, but because in the training data, asthma patients tended to get admitted and receive aggressive care faster, leading to better outcomes. The AI learned a misleading correlation.
So you can't trust the reasoning.
Not always. This is why the EU's GDPR includes a potential right to an explanation for automated decisions, and why DARPA launched its XAI Explainable AI program. We need to understand the why.
Okay, moving towards even bigger risks.
Yeah.
What about misuse by governments or others?
Yeah, the threat of bad actors and weaponized AI. AI could certainly help authoritarian regimes efficiently control their citizens through advanced surveillance, micro-targeted propaganda, and sophisticated digital warfare tools. It lowers the barrier for certain kinds of attacks.
And finally, the really big one, existential risk.
It's a conversation we have to have. Existential risk. Some very prominent AI experts, Geoffrey Hinton, leaders at OpenAI, have issued stark warnings. They view mitigating the risk of extinction from AI as a global priority, on par with pandemics or nuclear war.
That's sobering.
It is. Now, it's important to say not everyone agrees. Other leading researchers like Jürgen Schmidhuber or Andrew N. are much more optimistic about controlling AI development. But the fact that such serious people are raising these alarms means we have to take the possibility seriously.
Absolutely. Okay, these are massive, complex challenges. So what are we actually doing about all this? Is there a path forward?
There's definitely movement. The world is waking up to the need for AI regulation.
We're seeing more laws.
Definitely. There was a huge jump from just one law passed globally related to AI in 2016 to 37 in 2022.
Wow.
And there are international efforts like the Global Partnership on AI, a UN advisory body on AI governance, plus concrete legislation is happening. The big one is the EU Artificial Intelligence Act, set to come into force in August 2024.
The first major comprehensive AI law.
Pretty much. And the Council of Europe recently adopted a framework convention on artificial intelligence. Public opinion on how much regulation is needed varies, but the trend towards establishing guardrails is clear.
So regulation is part of it. But amidst all these risks, is there a model for how humans and AI can actually work together constructively? Not just AI as a tool, but as a partner.
That's where the concept of hybrid intelligence, HI, comes in, and it's a really compelling vision.
Hybrid intelligence.
HI is defined as the synergy between AI's speed and analytical rigor and NI's depth of insight. NI being natural intelligence, human intelligence.
Synergy. How does that work in practice?
Think of a neurosurgeon performing a really complex, high-risk operation. Her years of training and experience are invaluable. That's the NI.
Right.
But maybe she has an AI assistant analyzing millions of similar surgical cases in real time, monitoring the patient's vitals with incredible sensitivity. The AI flags a subtle pattern, a potential complication, milliseconds before a human could possibly detect it.
Ah, an early warning.
Exactly. The surgeon, alerted, uses her judgment and skill to intervene instantly. The AI didn't do the surgery, it didn't replace her judgment, but it amplified her capability. It extended her senses and analytical reach. That's leveraging the best of both.
That's a powerful analogy. It highlights how our human natural intelligence is so much broader, isn't it? It includes our aspirations, emotions, thoughts, sensations, both individually and, importantly, collectively. Our empathy, creativity, collaboration.
Exactly. Those are the uniquely human strengths that AI can augment, not replace. And cultivating this hybrid intelligence effectively requires what some call double literacy.
Double literacy.
Understanding both human cognitive processes, how we think, feel, decide, and AI mechanisms, how the algorithms work, their strengths, their limitations. This allows leaders, for example, to interpret AI-driven insights through the lens of human values.
So you can use the AI's power, but ensure it aligns with what actually matters to us.
Precisely. Frameworks like the A-frame, standing for awareness and appreciation, are being developed to help organizations consciously implement HI, making sure AI serves broader social and environmental goals, not just narrow efficiency metrics.
But even this positive vision of hybrid intelligence isn't risk-free, is it?
No, absolutely not. There are definite pitfalls. A big one is over-reliance on algorithmic outputs.
Just trusting the machine too much.
Yeah, letting human judgment atrophy or be ignored. Another is neglecting collective dimensions, focusing only on individual productivity gains from HI, perhaps, while ignoring wider societal impacts or community well-being.
So human oversight is still crucial.
Paramount. Constant critical thinking, ensuring alignment with ethical principles and community objectives, keeping the human firmly in control of the goals and values. It's about designing systems for collaboration, not abdication.
It really underscores how vital it is to understand AI's ethical landscape and be proactive in shaping a future where this incredibly powerful technology serves human values, not the other way around.
Wow, what a journey we've taken today. We've really tried to unpack AI from its fundamental building blocks and that roller coaster history of winters and booms to the specifics of tools like CNNs for vision and RAG for making language models more factual. And we've also had to grapple with those essential ethical debates, privacy, bias, existential risk, and finally the hopeful possibility of hybrid intelligence.
Yeah, and it's so important to remember AI isn't just, a pile of algorithms. It's a mirror. It reflects our ingenuity, our goals, sometimes even our flaws and biases. Understanding its complex, multifaceted nature is just essential for navigating the world we live in now and the one that's coming.
Absolutely. Well, thank you for joining us on this deep dive into artificial intelligence. We covered a lot of ground. And maybe a final thought to leave you with. As we continue building ever more sophisticated AI, what truly new forms of intelligence might emerge when humans and machines genuinely collaborate? And maybe more importantly, how do we actively ensure that whatever emerges aligns with our deepest human values and our collective well-being? Something to think about.